Well, this is the second half of our visual of electrons, and once again, I just want to really make sure that we understand that what we're looking at here is electrons. We're saying to ourselves, here's this nucleus, okay, that contains the neutrons and the protons, and here's the electrons that travel around. And what we're actually saying is, wow, those electrons can actually leave and go away from that nucleus, and we can get bonds, and we can get reactions, and we can get ions, and all the different things we're going to talk about in chemistry. We got to understand electrons. We got to get electrons off of that page of the textbook, and we got to get them off that little diagram, those little dots going around that makes everything look one-dimensional. Well, we got to make this two-dimensional, three-dimensional, even six-dimensional when we talk about SP, D, and F electrons. So once again, refresh our memory. The last thing we did on the last video was we had the once again, we had the complete circuit here, okay, and we put that on the 5,000 volts there, and when we did that, we actually took that, there we go. So it lit up the bulb. So what's that telling us? That the electrons actually, as long as we can make a circuit, electrons can travel. Now, we also have to refresh our memory on what we've already learned, in that even though we don't have an aluminum ring here, okay, or wires or something, we still release electrons. Electrons are still being released. So once again, even though those electrons are going into the atmosphere, we have to realize that there's still something going on. Energy can't be created or destroyed, it only changes form. So we still put 5,000 volts of energy, okay? So what happens to electrons when they travel just into space? Well, electrons have a negative charge, all right? An atom wants to be stable, wants to have its zero charge. So electrons are a negative charge. So when they are in the atom, okay, there's the same number. It's the same number of electrons as protons, called the atomic number. So the atomic number of hydrogen is 1. There's 1 electron and 1 proton, and so forth. So when we look at carbon, it has the same number of electrons, same number of protons. Every element in the periodic table, the atomic number is the number of electrons and number of protons. Why is that significant? Because that means it has the same number of negative charges as it does positive charges, so when they combine, it makes a zero charge. It's stable. Now, we try to make everything superhuman, don't we? Okay? You know, I mean, even little kids, it's like, hey, it's Mr. Broccoli, oh boy, you know, and Mr. Broccoli's human and he can think and all this stuff. Hey, how about cars? I mean, you know, that works, okay. Hey, I'm a car, I don't have a driver, I can just be myself, okay. But that's really nice for cartoons and for little kids, but we got to realize electrons don't have a brain. They can't think. They only have one function in their existence, and that's to become stable. And no matter what happens, the electron's going to become stable. So when I release these electrons into the air, okay, they're going to try to become stable. They're going to find something else. What's the charge of an electron? -1. So it's going to find a +1 charge out there, and it's going to combine, it's going to become stable. So what if we can't find enough charges? Oh, well, have you ever heard of a lightning bolt? A lightning bolt is a ton of negatively charged ions that are looking for something, and then whenever they discharge, all that electricity comes out of the sky, and all of those negative electrons come out, and they're looking for what? Something positive. Because every negative charge is going to need a positive charge to make a zero stable charge. That's the key. So now, that being said, let's move on a little bit, okay? So I had 2 rings, 2 aluminum rings, okay? When we did the last video, the one with the solid ring, once again, we remember what it did. It shot up in the air, okay? We don't need to make an inference on that. We already know that. And we talked about the one with the slit that's got about a 1 millimeter slit in it. We're going to put that down here, okay? And when we push that, it doesn't take off. But let's go one step further, because science, knowledge builds on knowledge. If we know this, then we need to know this. If we know that, then we need to know that. If we know this, then we want to know this. If we know this, then we're curious about what's the next step. So, if that's the case, okay, if that's the case, let's put this one with the slit on the 5,000 volt generator. And then, let's take the regular one and let's put it on top. Now, we're learning a lot about electrons, because we talk about covalent bonds, we talk about shared bonds. We've got one slit here that doesn't go up and one that does, but all of a sudden I'm putting them together. So what's your inference? Now, you got to make an inference. What do you think is going to happen? Now, if you don't make one, you're cheating, okay? Because once again, why do we have to make an inference? Why do we have to make a hypothesis? Because when you're right, you have to think in your brain, why was I right? What was I thinking that was right? Because I want to keep thinking that, okay? But when your inference is wrong, then you want to say, okay, what did I miss? What was the hidden piece of evidence? What did I learn that the next time I make an inference that's right? Okay? So, let's think of an inference. Okay? Now, you can't be like, okay, just count down to 5 and let's see what happens and then I'll know. No, you got to think like a chemist. Okay. All right, so 5. What do you think is going to happen? 4. What do you think is going to happen? 3. What do you think is going to happen? 2, 1. Oh, well, look what we had. Okay? The one with the slit stayed. The one without the slit went up, but instead of going the 10 feet that it went last time, it went about 8 feet. But it's not really warm. Oh, so what does that tell us? So remember, energy can't be created or destroyed. It only changes forms. We put 5,000 volts into that system, so what does that tell you? Oh, that tells me when I pick this one up, I need to what? I need to be a little careful. It's cooling down as we go. But this one is pretty warm. Why? Because the energy that I put in that system that caused that ring to go up 10 feet the first time, it only went up 8 feet, which means that I have a system there that's going to have either heat, okay, caused by friction, or it's going to have motion. It's just like your car. We put oil in your car to try to reduce friction between the gears that are turning and all the moving parts. So if we have friction in your car, then we go into your engine and your engine's hot. Boy, you touch it, you're either going to have heat or you're going to have motion. So what do you want for an efficient car? You want more motion and less friction, less heat. So you want a really good motor oil in there to cause less friction, because when the parts go together, you're going to put the same amount of energy in the system. So you're either going to produce energy in the form of motion or heat in this case. So now let's switch it, okay? All right, so what did I do last time? I put the one, and it's starting to cool down, that's good. So I started to put, now what would happen if this was really hot and I put it in there? Oh, well then I would already have some energy in the system and it would cause it to go up higher. But instead, this time, what I'm going to do, instead of putting the slit down first, I'm going to put the regular aluminum ring on the bottom, and then I'm going to put the one with the slit on top. Okay, so you already know. I don't even have to tell you as a teacher. Now you're beginning to look. Now you're beginning to learn. Now you're like, I don't need a textbook to tell me, okay, what's step 1, what's step 2, what's 3. Now you're already like, okay, I think this will happen. I don't even have to ask you. You're already going, oh, I think this will happen. So you're going to go 5, 4, 3, 2, 1. What do you think is going to happen? Well, I'm not going to give you a multiple choice. There's a lot of things that could happen. And because we're learning electrons and because we're learning science, when it does happen, we're going to be like, oh, and I know why. So let's see what happens. 5, 4, 3, 2, 1. Oh, okay. Wow. Okay. And they are medium warm. Not hot, but medium warm. But what happened there? Okay. Well, let's look at this. Okay. So we're talking about electrons. The electrons went into the ring, charged the ring, made the ring a negative charge. The ring itself had no charge. It was not positive, it was not negative. That's the beauty of aluminum. That's the beauty of aluminum. The charge goes quickly, okay? So, when I put all the negative electrons in there, I made this charge of this, I made the charge of this negative. What did I send out? Electrons negative. Like charges repelled each other, okay? Now, why did this one push it? It was kind of like this one supplied the energy. It was wanting to go 10 feet. The one with the slit didn't absorb the electrons. Instead, it was just carried by the positive one. How high up? About 4 feet. Oh, so why did I not think there would be a ton of heat? Because the two of them, 4 feet, is going to equal 8 feet total. Because once again, the total energy in the system. So I knew they would be a little bit warm because I didn't do all the motion. I knew it could go 10 feet. Okay, kind of interesting. Now we're going to really test you. Okay, now we're going to really test you. All right, so we kind of know what's happening. Now, let's look at this. Now, we have in this device here, okay, we have a plexiglass ring on the bottom. Okay, we have a plexiglass ring on the bottom. All right, it's a spacer, okay? It's a spacer. And that spacer puts this to where it's almost in the middle of the electrical circuit, okay? I'm going to take this off, okay? See what I'm doing? I'm going to take this off. Now, why did this not go up in the air? Because it's not a conductor of electrons. Plastic is not a conductor of electrons. If I have a screwdriver with a plastic cover, hopefully I'm not going to get shocked if I touch an electrical current. Don't try it, okay? Don't try it. It might not be a perfect plastic. Okay, so I'm going to take this off. Now I'm going to put this on the top. Okay? Now, all right, here we go. So now I'm going to put this on the top, and I want you to think of a hypothesis. Okay. All right. So, well, once again, anything can happen. Now, it doesn't really matter what your hypothesis is. We just want to try to think, okay? So, you might think it's going to go up super high because now we moved it down low. You might think it might not go as high. You might think it might get hot. You're not sure exactly what's going to happen. So, make an inference to the point to where we really don't know what's going to happen. So, just make one, and then we're going to learn from it. Okay. All right. 5, 4, let's make sure, be ready on the camera to go all the way up to the sky here. 5, 4, 3, 2, 1. Oh, came off great, but the only problem is it's extremely hot. Okay, it's extremely hot. Now, okay, as I do that, okay, I have another spacer. Okay, so you see when I took off the first spacer, it went really high, and it almost did the same thing. But now I'm going to take off both spacers, and now let's look at where this is at. So now we're going to move this down, okay? So now what we have is it's on the bottom third of the copper wire, okay? So if your last hypothesis was that it would not totally affect it to take the spacer off, it did have a little more heat, I would say, okay? I would say it had a little more heat. But now, think of a hypothesis, and you're like, something's got to happen or he wouldn't do this, okay? 5, 4, 3, 2, 1. Wait a minute. Wait a minute. You mean when I take those spacers off, you mean all of a sudden it doesn't go anywhere? Now, you do know one thing. What have you learned about electrons? We did put 5,000 volts in there, so what are we thinking? You notice how I'm not reaching down there really quick to grab it? Well, I'm not a total idiot, okay? But I do need to be careful because it's absorbed a lot of heat. But why did it not go into the air? Okay, really warm, okay? So let's look at this, okay? Let's look at this. All right, bottom spacer. What do we have? A slit in here. We're going to put it in. Okay, we're wrapping this thing up. And then we have another spacer. So what's happened here, the ideal thing is that we've got that towards the top. Why? Because as the electrons travel in the coil and they become loose, we have to absorb all of the free electrons. Okay? Well, what's towards the bottom here? Oh, a metal plate. Even it's absorbing electrons. We've got to look at everything in the environment. So now we get it away from the metal plate. We put it up here in the middle to where this is going to absorb most of the free electrons. And once again, here we go. Boom. So, really hot. And once again, let's wrap this up. What are we studying? Electrons. What do electrons do? Electrons want to be stable. Every negative charge of an electron needs to find a positive charge. Do electrons have a brain? No. What do they got to do? They got to become stable. What did we see? Energy can't be created or destroyed. It only changes forms. What are forms of energy? Heat, motion, movement, electrons, atoms, bonds, chemicals, molecules. That's where it all starts. See you for the rest of the class.